All right, let's jump right in. We're about to tackle one of the most, well, profound and, frankly, one of the weirdest ideas in all of science. It's a concept that comes straight out of quantum mechanics, and it completely rewrites our rules for what reality even is.
And that's the real kicker, right there. This isn't about us having clumsy hands or our measurement tools not being good enough. This is the universe itself saying, nope, there's a line. There's a fundamental limit to what you are allowed to know for certain.
So, what is this cosmic rule? Well, let's give it its proper name. We are talking about the Heisenberg Uncertainty Principle, which was first figured out way back in 1927 by the absolute genius physicist Werner Heisenberg.
So what does that actually mean in plain English? Think of it like this. The more precisely you nail down where a particle is, the less precisely you can possibly know where it's going. And, flip side, the more you know about its momentum, where it's headed, the fuzzier its actual location becomes. It's a mandatory cosmic trade-off. You can't have both.
Okay, I know. Math on the screen. But hang with me, this is actually pretty simple. All this equation is really saying is that the uncertainty in position, that's the delta x, times the uncertainty in momentum, delta p, can never ever equal 0. It always has to be bigger than some tiny but very real number. So the bottom line is, if you squeeze one of those uncertainties down, the other one has to shoot up to keep the equation balanced.
And I really want to hammer this point home because it's the number one thing people get wrong. This is not a measurement problem. It's not like you're trying to check your tire pressure and you accidentally let a little bit of air out. No, even if you had magical, perfect instruments that didn't disturb the system at all, this uncertainty would still be there. It's literally baked into the source code of the universe.
Which of course leads to the big question, right? If it's not us messing things up, then why? Why does this rule even exist? Well, the answer is tangled up in another one of those mind-bending quantum ideas.
Yeah, exactly. It feels so wrong, doesn't it? In our world, the macro world, you can see a car, you know where it is, and you know how fast it's going. Why on earth would a tiny little particle play by a different set of rules? And here it is. This is the secret. An electron or a photon, they aren't just little billiard balls zipping around. They have this dual nature. Sometimes they act like a particle, a little point, but other times they act like a wave, all spread out. And this wave-particle duality, that's the source of all the weirdness, including uncertainty.
So to really get this, let's think about something we're all familiar with: sound. A pure single musical note has a very specific momentum, right? But it's a wave that stretches on, so you can't really say where it is. Now, to create a short, sharp clap, a sound with a very precise location, what do you have to do? You have to mash together a whole bunch of different frequencies, a whole bunch of different momenta. It's the exact same principle for a quantum particle's wave. A precise position requires a messy mix of momenta.
And this just shows what an absolute bombshell this was for physics. You have to remember, for hundreds of years, we built our understanding of the universe on the idea that if we just had enough data, we could predict the future perfectly. It was all a giant clockwork machine. And then Heisenberg and his contemporaries came along and basically said, actually no, the universe at its core is fundamentally fuzzy.
Okay, so at this point you might be thinking, this is fascinating, but it's just some weird abstract theory for a physicist in a lab, right? What does it have to do with me? Well, it turns out it has to do with everything.
Get ready for this, because it's one of the most mind-blowing consequences of this whole thing. The only reason you and I and this entire planet don't collapse into an infinitely dense speck is because of the uncertainty principle. You see, when you trap an electron inside the tiny space of an atom, you've made its position really certain. So what happens? Its momentum has to become wildly uncertain, meaning it zips around with a huge amount of energy. This energy acts like a kind of quantum pressure that holds the atom up, making chemistry and us possible.
And it doesn't stop with just keeping matter from falling apart. Look at all this modern tech, the very things we use every single day. The little semiconductor transistors inside your phone, they operate on quantum principles, lasers, nanotechnology, and a little thing called quantum computing, which is trying to harness this very uncertainty to solve problems we can't even dream of today. It's all based on this.
And by the way, this isn't some one-off deal between position and momentum. Oh no, this quantum trade-off rule applies to other complementary pairs too, like energy and time. The more you know about a particle's energy, the less you can know about how long it exists in that energy state. It's a universal feature of the quantum world. So you see, this is not just some historical footnote from the 1920s. The uncertainty principle is alive and well, and it's right at the heart of some of the most exciting, cutting-edge research happening today. It's a true frontier.
I mean, check this out. Researchers are basically weaponizing uncertainty now. In the field of quantum cryptography, they use the principle to create totally unhackable communication lines. How? Because if a spy tries to measure the quantum signal to read it, the very act of measuring, because of uncertainty, disturbs the signal in a way that the legitimate users can detect instantly. They turned a fundamental limit into the ultimate security feature.
And that's really the thought I want to leave you with. Einstein taught us that the universe has hard limits on what we can know with perfect clarity. But by leaning into that fuzziness, by embracing that fundamental uncertainty, we've unlocked entire new worlds of technology and understanding. It really makes you wonder, what other incredible secrets are still hiding inside that uncertainty, just waiting for us to find them?